Okay, 1.4 is formulas and problem solving. Basically, it's giving you a formula and having you isolate a variable. We did this in Algebra 1. I just want basically a review over this. That's why we're doing it. So, as we go through a few of these, I'm going to do the evens from your homework. So if you want to pull out your 1.4, I'm going to do some of the evens just to show you what it looks like. And then pretty much that whole assignment is just so that you can practice it. So on 1.4 on your homeworks and look at the even ones. On number 2, it gives us I equals PRT. So this is interest equals principal multiplied by rate multiplied by time. That's the full thing. And then they say solve for P. So this is 4P. So basically I want to isolate this letter is all it's asking us to do. So how do I get rid of multiplying by R and multiplying by T? Divide by them. Really simple, right? Those cancel out, and I divide right here. So P then equals interest divided by rate multiplied by time. And that's it. Pretty simple. Okay, number 4. This one's a little more involved than that one was. It gives you AX plus BY equals C. That's basically standard form. It says solve for Y. So basically you're converting a formula into y equals mx plus b. So this is from standard to y equals mx plus b. And I have to isolate first this term. So how do I get rid of an ax added to a by? Hold on. If I were to move whole terms, I add or subtract them, right? So I'm going to subtract ax. Subtract ax to both sides. That is now gone. I'm left with by being equal to c minus ax. How do I get rid of the b? Divide by b. So when I rewrite this, I'm going to rewrite it with c over b subtracting a over b. X. Okay, I know this doesn't look like y equals mx plus b, but let's think about what it really is. This is a number next to the x, so that's be our slope. This is just basically a number, so that would be our y-intercept. Okay, if I reordered it, it would look more obvious, but that is y equals mx plus b, ultimately.
So why is x more than divided by b?
It is. Right here, divided by b. Do you want me to put the a and the x right side by side?
Can you do that, or is it wrong?
No, it's right. I write it like this because slope is easier seen when x is out to the side. It's easier to isolate it. If I wrote, here's my little side note, okay? So if I wrote 3/2 x and asked you to identify the slope, you would tell me m is 3/2. However, if I told you 5x over 2, identify the slope, most people will go, oh, that's a little harder to see.
Oh.
They'll have to rewrite it as math teacher, not English. Sorry. So anyways, that's why it's a little easier to read, is why I did that. Just a little easier to read. Okay. Any more questions before I move on? You still need that?
No, you can get it where it's there you go.
Okay. I'm going to jump a few here. I'm going to go straight over here to number 8 because that's one that we see all the time, and I feel like you need to know what it is. So this is the conversion from Fahrenheit to Celsius. So Celsius is 5/9 of Fahrenheit subtracted by 2. 32. Okay, and basically what they're going to ask us to do is convert it from Fahrenheit to Celsius, that's the conversion we're seeing now, to Celsius to Fahrenheit. So we're isolating F. So in order to get rid of this stuff that's making the parentheses impossible, remember that we do order of operations backwards. So addition and subtraction go together, and multiplication and division go together. So I'm doing order of operations backwards when I'm isolating stuff. So here, I'm looking at my parentheses. Okay, I have to look at everything outside of my parentheses, because on order of operation, we look at everything inside our parentheses, right? So we have to look at everything outside of our parentheses first. Now we go, is there any addition and subtraction? No. Is there any multiplication and division? Yes. There's 5/9 being multiplied right here. So how do I get rid of a 5/9? I would divide by it. So I'm really not dividing by 5/9. I'm multiplying by So it's 9/5 multiplied by c on the left side then, right? So I have 9/5 c equals, now I can drop my parentheses, f minus 32. How do I get rid of a minus 32? I add it. So I get 9/5 times Celsius, add 32, and that will be our conversion from Celsius to Fahrenheit. Okay, really good to be able to move these in between each other. There's those two formulas. You'll use them a lot in science, especially when you get into like chemistry and stuff. Yeah, that's the total answer. We isolated F just like they asked us to. What number? You want to do 10? Okay, let's do 10. That one is, looks like surface area of a cube. So this is area is 2 of the length multiplied by the width plus 2 of the length multiplied by the height plus 2 of the width multiplied by the height. So that looks like surface area of either a cube or a rectangular prism of some sort. So it wants us to isolate for L. So this one's kind of interesting because, first of all, 2 of our terms have L in it. So I'm going to isolate the 2 terms that have L in it. So I need to get rid of everything else. How do I get rid of this one right here? So 2HW would be the proper way to write that, right? So subtract 2HW. That goes away. So I have area minus 2HW equals 2 multiplied by L, W plus 2LH. How am I going to get L by itself is my question now. See, we can't do that because I would have to divide this one by 2W and this one by 2W, and then my L would be still locked in right there. Greatest common factor. So basically I need to factor this first, right? What am I going to factor out?
2L. 2L.
I could factor out a 2L if I wanted to. I could factor out a 2L. But what do I want by itself? I want L by itself. But if I factor out a 2L, now I have a 2 next to my L again. So I'm not going to factor out 2 and L, just because I think it'll get rid of a step. So if I factor out an L, it'll get rid of this and get rid of this. So I'm going to rewrite it so that we can look at it. So we have this translated is A minus 2HW equals, I've now factored out the L, so the L is on the outside, and I have 2W plus 2H. So the reason I'm going to go over again why I didn't factor out the 2. If I would have done that, then I would have had a 2 out there with my L, and I didn't want that to happen. How do I get rid of an L multiplying by a, I would divide by what? 2W plus 2H. I'm going to divide by the entire thing. Okay, so I'm dividing by the total, same thing on each side. So that goes away, and our overall answer will look like, sorry, I ran out of room on my paper here, A minus 2HW over 2W plus 2H, and it all equals the L. Now, I will give it to you that it is a lot easier to solve these kinds of problems when there are more numbers involved, but we have to be able to know the general way to do this. In college math, you deal with a lot less numbers than we already did. Okay? So here you go. Any questions on that one? All right. Jump over to the back side of that paper. We're going to look in that 23 to 27 range. Let's do 24. These are, my teacher called them river problems. Some people call them airplane problems. Either way, they kind of go the same grain. So here we go. A grain barge travels on a river from point A to point B. So I'm just going to draw a little picture to illustrate what we're doing here. From point A to point B. Loading and unloading grain. The barge travels at a rate of 5 miles per hour relative to the water. The river flows downstream at a rate 1 mile per hour. So if the trip upstream takes 2 hours longer than the trip downstream, how far is it from point A to point B? So I need to make some little notes here because there's a lot of information to go through. So I'm going to use things like distance is going to be the same no matter what, right? Regardless of whether they're going upstream or whether they're going downstream, distance is the same. I'm going to let distance be d. So distance, because we don't know it, is just going to be the variable d. Okay? Now, as I read through this, we need to pick out some stuff. The barge travels at a rate of 5 miles an hour. So the barge travels at that. So I need to make the note of barge speed, right? So barge speed is 5 miles per hour. I just put B sub s for barge speed. You can use whatever variables you want, but for this example, let's use B sub s. So the river flows downstream. So downstream, I'm going to put, I'll put D sub s for downstream at 1 mile per hour. Okay, so if the trip upstream, so we're talking time, right? So time up, or T sub u, the time upstream is 2 more hours than the time downstream. So the time up is the time down plus 2. Okay, has anybody got any confusion with this stuff at all? Primarily the last one is the important one, so. Any confusion at all? Just a lot of little notes. I'm going to give you a second to copy the rest of that down if you haven't already. Distance is going to be a lowercase d. We're going to use that as a variable. The barge speed is 5 miles an hour. The downstream speed of the water is 1 mile an hour. And the trip up takes 2 hours longer than the trip down. Okay. So I think that's everything in the problem that we need to do. Remember what we're answering. We're answering for distance. This is the question. We're solving for distance. How far is the trip? So we need to start establishing some equations to help us with this. So if the trip up equals the trip down plus 2, that's a good equation. We're going to use that. We're going to use what goes together with distance, time, and rate. What equation is that? Dirt, right? D equals RT. So distance is rate times time. So let's think about it. We have a rate. What is our rate when we are traveling with the water? But the water is pushing us an extra mile an hour, so it's 6, right? So the rate downstream, as in we're going with the water, so the rate downstream is going to be 6 miles per hour, right? And therefore the rate upstream is going to be what? 4, because the water's working against us. So now I have a little extra information that I can pick from common sense. So now that we know we're going to use dirt, we're going to start making some stuff up that goes with this. Okay, so distance is going to be the same. So distance is, we're going to talk about the rate downstream, which was 6, multiplied by our time. So since this is our rate downstream, we have to use our time downstream. So this is 6 multiplied by our time down. Whoop, I did that differently than I wrote it over there. Let me write it the same as I did on the right. So it was a capital T sub D. Right? Our time down is just time, capital T sub D. So I put in distance, I put in my rate, I put in my time. I'm going to put in the same things for my upstream. So my distance upstream is going to be the same. My rate upstream is what? 4. And my time upstream was what? Right here, right? TU. But I can plug this in, right? It is TU, you're right. T sub U. But I want both of these equations to be in terms of TD. That'll help me out later. So what property did we use? What did you do, Bonnie? What did you do for this? I plugged it in. In other words, they're no longer a bench warmer. They did what? Substitute! Okay, it's substitution. That is just simply the substitution property of equality. If TU is this, then I can let it be that thing when I plug it in. So that's all we did, substituted it. Okay, so now we have two equations. We have this one here and this one here. I can make this one a little easier to read, but ultimately I have both the same distances, right? So this kind of more complicated problem becomes a lot easier when I set them equal to each other. So 6t sub d equals 4, open parentheses, t sub d plus 2. It becomes somewhat easier because I get to distribute and solve. I only have one variable now. I only have one variable, so my life is easy. Again, you don't have to use my variables. They might be confusing to you. You can use x and y. I don't care. Okay, distribute out my 4. So I have 4 t sub d. And distribute out my 4 to the 2, and I get 8. And I didn't do anything on the left, so I'm just copying that down. Next, what do I need to do? I need to subtract my 4 t sub d from both sides. And I'm left with 8 on the right, and I'm left with 2 t sub d on the left. How am I going to get t sub d by itself? Divide by 2. So t sub d, or the time downstream, is 4 what? Uh-oh. What are we talking about? Let's read this again. What is t sub d? What does t stand for? Time downstream. So 4 can't be 4 miles an hour. It can't be 4 miles. It has to be hours, right? So 4 hours downstream. Now let's make sure we're going to answer the question. If the trip upstream takes 2 hours longer than the trip downstream, how far is it from point A to point B? Now that we know the time, we can plug back in to find the distance, right? So I can plug in either of these two equations. Obviously, I'm going to plug into the easy one, which is this guy. So my distance is 6 multiplied by 4, and my answer would be 24 what? Miles, because we're talking miles per hour, so it has to be in miles, right? I know this is a lot of information to write down. I realize that. But ultimately, we only dealt with 2 equations. Most of the time, in Algebra 2, all we had to do was get these 2 equations and solve. Now you have to come up with them by yourselves. Okay? So that's going to be a hard transition. When you get to that problem on your homework, just call me over and we'll start diving through it. Make sure you have this set of notes on you when you go to do that problem. Yes?
Why did you multiply the 2 times? How did you do the rate
Tell me what equation we're looking at here.
the last one? What changed the hours?
Yes.
Why did you use the 4 hours?
Because the time downstream was 4 hours, so 6 multiplied by my time, which gives me 24. I could have plugged it in here. Is that what you're asking me? If I would have plugged it in here, it would have been 4 plus 2, which is 6. 6 times 4 is, again, 24. Because the distances match. It didn't matter in this particular case.